All right, so welcome back. Today in this video, we're going to be looking at more surveying review for the Civil FE exam. And we're going to be focusing specifically on earthwork and volume computations. So if you have, if you haven't checked out some of the other videos on my surveying, in the surveying section, then make sure you check those out. I go through angles, distances in trigonometry, area computations, and I'll also be going over coordinate systems and leveling. So all very important topics. So let's look at earthwork and volume computations. So for number one, it says using the average in area method, calculate the volume in cubic meters of earthwork for a road cut with the following cross-sectional areas. All right, 500 meters at the start and 400 meters squared at the end. The distance between the cross-section is 50 meters. All right, so what information are we given? Average and area method. That's what method they want us to use. We get the area, the cross-sectional area at start and end, and we get the distance between, which is the 50 meters. All right, so basically you're doing a road cut. Let's see if I can draw this out for you. So this is a vertical view of the road, right? And so you have the road, you have, let's say you have some dirt, right? Soil underneath your road. And then you got this little worm here crawling underneath the ground, trying to stay out of the way. All right, and so basically what we're doing is we're cutting a section out of this road. And I'll even spice it up and put a little car here, just so you get a picture, a mental picture. Okay, so along this road, the distance in between the cross-sectional areas, right, we're going to take a cut out of this road, and I'm just going to say cut from here to here, and we're going to say that is 50 meters, right? 50 meters from there to there. Okay. And so along that, you're going to see the cross-sectional area at the start, and that's going to be the 400 or the 500 meters, right here. And then the second at the end is going to be 400 meters. And so the way that that looks, right, is this road width is only so far over, right? So we just look at the full road. We know it doesn't go super far, but basically you're looking at the cross-sectional area. of this slice all the way along. And that is going to be your 500 meters squared, 400 meters squared. So you're trying to find the volume of the whole piece, and we're using average n method to do so. Okay, so hopefully that gives you kind of a visual of what's going on. So we're trying to find the volume. And okay, let's look up what average end. Okay, one thing that comes up, average end formula is equal to V, which is volume, is equal to the length times area 1 plus area 2, all divided by 2. All right, what's the length? The length is our 50 meters, was area 1, the area at the start, 500 meters squared, and area 2 is 400 meters squared. So everything is pretty straightforward. So I'm going to say this is equal to 50 meters times my area 1, 500 meters squared, plus 400 meters squared, all divided by 2. And so I am left with 22,500 meters cubed. Cubic meters. Okay, so I'm left with answer D. Let's look at number 2. Number 2 says compute the volume of excavation between 24 plus 00 and an N area of 711 meters squared. Compute the volume of excavation between station 24 plus 00 with an N area of 711 meters squared and a station 25 plus 00 with an N area of 515 meters squared. All right, so it's important to note for this is in meters. These stations are in meters. So they give us stations. They also give us what else do they give us? They give us the end areas station, and they want us to find the volume. Okay, so similar idea here. We're gonna do pretty much the same thing that we did in number 1, but so we'll use V is equal to L times A1 plus A2. And just keep in mind, this is not it's the average volume. It's not going to be the exact volume, but it is the average volume. Okay, so what I have this is going to be my A1, right? 711 meters squared. This is going to be my A2. What would my length be? Well, my length is the distance between two stations. So I have 24 plus 0, 0 is one station, and then I have another station, which is 25, 0, 0. So what does that mean? All right, 25, 0, 0. It just means 2,400 meters and 2,500 meters. That's the distance. So we still have our road. Just to give you some context. All right, we still have our road. We still have our cool car coming across. So what is the length between the two stations? All right. Well, the length is just going to be length is equal to 2,500 meters minus the 2,400 meters. And that gives us our length is equal to 100 meters. Cool. Okay, so that is the distance between those two stations. Alrighty, so now I have my length, I have both of my areas, so now I can solve. All right, so this is equal to 100 times 711 plus 515, all divided by 2. This is going to give us 61,300 meters cubed, or C. All right, so let's look at number 3. So it says a civil engineering project involves earthwork computations for a road construction site. The mass haul diagram is utilized to optimize cut and fill operations. What is the primary purpose of mass haul diagram? All right, so we're given some answers. Answer choices, and we know that we're trying to also looking at mass haul diagram. All right, and we're trying to find the purpose of using a mass haul diagram. MHD sounds fancy. All right, so let's search. So I don't know what a mass haul diagram is. All right, mass haul diagram. All right. There are some balance points on this diagram. You have, so there's a place where you can balance out your, you have your existing ground, right? And you have your proposed ground. And if you cut and fill in certain areas, it will balance this thing out. And so you can find your balance point, right? Mass haul ordinate is a cumulative, Mass haul ordinate is the cumulative total of excavation and embankment at a given station. Okay. So what's the best answer here? To design road geometries? No. Road geometries is like how much the curve is going to be, or I guess, the geometry of the road, which means it could be curvy or flat. So that's wrong. To calculate pavement thickness, don't see anything about pavement thickness here. To analyze soil composition, so that would be like, what is the soil made of? Is it fine, or is it clay, or whatever? So no. To optimize distribution of earthwork materials. Yes, so you're optimizing where you're going to be distributing your cut versus where you're going to be distributing your fill. So D. Woo. All right, that concludes this section of the review. In the next video, we're still going to be in surveying, but we're going to be looking at coordinate systems. So I'll see you in the next one.